Hello everyone. How you doing? It's Friday, November 22nd. So, it's less than a week till Thanksgiving 2019. And I'm just going to do a quick series of talks on astronomy and the basics of exploring the night sky from your backyard. And I have this lovely backdrop here, which is the Andromeda Galaxy. And why the Andromeda Galaxy? Well, because it's the number one object in the night sky that is, just mind blowing. It is the deepest object that you can see with the night with your naked eye. Of course, through a pair of binoculars, it's a little better, and with a great telescope, it's a little better. And then when you start to take a photo where all the light can be captured over a period of time and just deposited onto the chip in a photo like this, then the detail is even more amazing. This would not look anything like this with the naked eye or even through a very powerful telescope, because our eye doesn't have the ability to absorb and record the light over time like a CCD chip or film does. So this won't look like this to the naked eye. It'll look like a blob. You'll see individual stars, not as many as these, but you'll see individual stars through a telescope. Or even through a pair of binoculars. This will look like a blur, a very big patch of sky. Takes up about 2.5 degrees, which is bigger in size, in the sky size, than the moon, which is only about 1 degree. So here you go. This is an amazing object. 2.4 million light years. What is 2.4 million light years? And we should probably try to put that into some perspective. What is a light year? A light year is the amount of time it takes light to travel in, or the distance that it takes light to travel 1 year in 1 year. Light travels 1 year in. Let me rephrase that. 2.4 million light years. What does that equal? That equals 2.4. Light travels 6 trillion miles in 1 year. So 2.4 million times 6 trillion. That's how many miles this thing is away. It's not even understandable, really, because what is the fastest thing we've ever built? The fastest spaceship we've ever built was the one that went to Pluto, launched in 2009, and it took 8 years to get there, or 9 years to get there, between 8 and 9 years. And it traveled 60,000 miles in a year. That's the fastest thing we've ever built. How long would a spaceship traveling 60,000 miles a year take to get to the closest star, which is about 4 million, not million, 4 light years away. 4 light years. To travel to the closest star at 60,000 miles an hour would take about 60,000 years. One way trip. So, unless we figure out a way to go faster, we're not going there in our human lifetime. And we're not going there very soon, because we're not even close to building something that can travel faster than 60,000 miles an hour. Light travels, as I say, 6 trillion miles in a year. The closest star we have is about 4 light years. So that's 4 times 6 trillion you can see the problem. We aren't getting there in a hurry. We're not getting there in even a fraction of a human lifetime. But at the same time, some of these things are so amazing that you have to try to understand what is it that we are seeing out there. What is this thing? Look at this galaxy. This is very similar to the Milky Way galaxy. This is in the local group of galaxies that consists of, I don't know, about a dozen galaxies. The Milky Way, the Andromeda galaxy, Triangulum. Uh, I don't know. There's I guess the local group of galaxies is in the around 10 to 12 million light years. This is one of the closer ones. This is 2.4 million light years away. Uh, so, I mean, to try to wrap your head around that is pretty tough in itself. You have to have some idea of how fast light does travel. And even as fast as it does travel, light travels 6 trillion miles in a year. We aren't approaching anything that we can make that can go that fast. The mind can go that fast. You know, when you look up at the night sky, you're seeing it. I'm seeing this object right now. I'm seeing this distant 2.4 million light years away. I'm seeing it right now. Wait a minute, what's going on here? I can see it. I can see some of the light. I can't capture it all, but I can see some of that light in the here and now, right now. And I can look over here and I can see something else that's a lot closer. Okay, so the mind just really doesn't have the ability to comprehend, I don't think. What are we seeing? What are we seeing when we see this object or other objects like it in the night sky? I saw an object once that was 9 billion light years away, okay? 9 billion. What does that mean? Well, we know the Earth, the solar system, is about 4.5 billion years old. And I saw something 9 billion light years away. That means that the light left it before the Earth and the solar system was even here. So what am I seeing? I'm seeing the light that has taken that long to travel. I'm standing on an Earth that was not even here when the light left that planet or left that object. It was a quasar, one of the most distant objects in the night sky. It looks like, it's so far away, and all it looks like is a very bright star. Anyway, I could go on and on. I love talking about this stuff. It's crazy stuff. The scale of the universe is crazy. Okay, here's another great way to have a rudimentary understanding of the universe. This analogy was given to me by our astronomy professor friend when we used to volunteer. A group of us used to volunteer at the Ecotarium. There was an astronomer friend there. He was a PhD in physics, and his explanation of the vastness of the universe was given in this analogy. Here we go. So we know that the universe is about 13.5 billion years old. That's what we know. I don't know how we know that. It's really a long, lengthy explanation as to how we know it's about 13.7 billion years old. Okay? How many seconds are in 13.7 billion years? And you could do that math. Here's how many stars are in the sky. This is the ones we know of, and I think when he told me this, we still hadn't made the leaps that we now have in our understanding of the vastness of the universe. I think this is probably an underestimation of how many stars there are. So if you took 13.7 billion years and the amount of seconds that have elapsed since the beginning of time, the universe would have to start over 7 more times. In other words, 13.7 billion to the 7th power in order to come up with the number of stars that we knew of at that time. And I think that number is well beyond that at this point. But it's just unfathomable. And that's what makes it amazing, is nothing else in daily life is as exciting as looking up at the night sky and knowing that this is what's up there. This is what we're seeing. And so much more that we can't see, that we will see, in the infrared light, a new telescope to replace the Hubble telescope. I think it's going to be launched in 2021 or 2022. It's the James Webb Telescope. And the James Webb Telescope will see in the infrared. And so it sees what an eye cannot see. It sees radiation in a different wavelength than what the eye can see. And it's estimated that the James Webb Telescope is going to do for the universe that we can't see, similarly to what the Hubble did for the light that we can see in visual light. This telescope is going to see in the infrared, and it's going to change our understanding of the universe. It's expected to expand the universe. So again, what I just gave you, those numbers are going to be ancient history. There's so many already. There's so many other stars that we've been able to image planets going around them. So we do know that there are hundreds of planets around other stars. We know there's literally billions of these things, that almost all star systems have some planets around them. But we've been able to prove that, and the way that we prove that is with very, very sensitive cameras and light and instruments. We watch a star that's many, many light years distant, and we are able to measure the intensity of the light coming from that star. And when a planet passes in front of that star, the light dims a little bit, just enough to be picked up, just enough to be measured in some way. And it happens on a cyclical basis. So we're able to see that, okay, we know there's something going around that star, much like the Earth is going around the sun. And we can measure the drop in light from our vantage point of what happens when we're looking directly at that distant sun. So okay, so there's a little bit of brief history of time, as Stephen Hawking used to call it. There's a brief history of some amazing things in astronomy, some concepts that I'd love to talk more about. I can talk a long time about this stuff. I probably have several hundred astronomy books that I've read in the last 20 to 25 years. When I first got into astronomy about 1997-ish, I got a pair of binoculars. I mounted those binoculars onto a tripod in a holding system, and I bought a telescope shortly after that. I built a telescope. I'm building another telescope, a little bit more sensitive than the last one, and I suppose that process will never end. I'll continue to build bigger, as we do as human beings, are building bigger and more powerful telescopes to see things and to understand things in a way that we don't understand them right now. So anyway, that's my first talk. Thank you for sticking with me all this time. I don't know how much time has elapsed, but It's not a subject that is you're gonna see, and I might post this on my Facebook page if they can post a video this long. Let's see what happens. Thank you for sticking with me, and hope to see you again soon.